Hopefully you guys are attacking these vocabulary questions, like look for keywords, highlight what you want, because you have to have a goal in mind from the vocabulary. Identify the stuff that matters. The fact that the safe is sliding in this tells you that it's in motion, and that's why they use this coefficient of kinetic friction, because it's in motion. It's in motion. But probably the most important thing in this problem is which? Yeah. And if you don't start making that connection right now to the fact that F net equals, in constant velocity problems, F net equals careful, F net equals, so Amran said MA because she's got the formula memorized, but constant velocity implies what for A? A is 0. So then the net force is 0. So any forces that might be acting on it have to be balanced. So if Peter pushes from behind and Michael pulls with a rope from in front, are they working together? They are, right? So both forces applied are acting in the same direction. If this is the safe, you have a 300 Newton force, and you have a 390 Newton force. That arrow should be a little bit bigger. If the forces are balanced, what needs to be pointing in the other direction? Because if there wasn't any force on the left side, those two forces would be unbalanced. And what do you know about unbalanced forces? They accelerate. But we've been told this is not an accelerating system. So there must be some force that's opposing this. Very nice. And how much newtons is this force of friction, Maria? To be balanced. It's got to match those other two, right? So 690. Now you can go to this force friction equals mu Fn. Solve for mu by dividing out Fn. So 690 divided by mg, where m is 300. So you can solve for mu that way. 690 divided by 400 divided by 9.81. It's a coefficient of friction similar to the one we got in the lab the other day, 0.23. Is there 3 sig digs? 2, 3, 4. Kind of messy. Okay, so hopefully you're starting to see how I do these problems, especially the way I attack the language. But then you always have to relate it back to the physics principles. And in this unit, the physics principles are essentially two big ideas. Are the forces balanced? Is it constant velocity or is it at rest? Are the forces unbalanced? Is it accelerating? You just have to check off that box. We can skip the applet for now. You guys can try this one. Draw a dot. Doesn't matter which way you put them. 500 can go one way. 378 can go the other way. F net is 500 minus 378. That's what Mr. Dubitz told me, 122. And then Imre told me that F net is always MA. How to find A? Divide out the mass. So the acceleration of this box, 0.61 meters per second square, in the direction that I've drawn my free body. Remember, the net force is in the same direction as the acceleration. So the way I've drawn it, this box will accelerate to the right. Pretty much by convention, you guys, I just always pick the bigger value to be positive. That way I can be left with a positive. And like even if this was going left, maybe I put 500 on the left, 378 on the right. It's the same thing. Okay, what force is required to give a 70 kilogram person an acceleration if the coefficient of friction is blah? So if you're accelerating, what does this imply? A is not zero, so forces are unbalanced. I highly recommend that you draw a point, and on that point you draw some arrows pick a direction you want this thing to travel. I prefer the right. If I want it to accelerate to the right, is there some force this way? So they ask what force, that's the force applied that you need to apply. The frictional force works against the applied force. So when I say F net, in terms of these two forces, what would you write? Just in terms of these two. You got it. She picked the bigger one, and she started with it. Then you take the smaller one, and that one works against it. And visually, all this means, in your mind's eye right now, pick up this arrow, the force of friction arrow, pick it up, and then lay it on top of this one. So like if I had a copy-paste tool, I don't know if I do. I do, but this arrow, pick it up, put it over here, and like that's how much cancels out. That's how much the force of friction works against that force. And how much is left over? Just this piece. This is left over. That is the F net. It's no different if you have like 20 bucks, you got 20 bucks, but then that little brother of yours, he gets 5 of it. And that 20 bucks becomes 15. You're like, damn. Your F money is 15 because that little brother works against you. Right? You're the applied force. You got 20 bucks. That was your allowance. But your little brother is a force of friction. He works against you. He takes 5 of it. So your F money is 15. Okay? So, what do we know F net is also equal to? MA. And that's the key. F net is equal to the sum of all forces. That's the thing on the right side. But F net is also equal to MA. So you have MA equals the sum of all forces. And what are we trying to solve for? Did you have to look back in the question? What are we solving for? Force applied. How do you isolate for the term force applied? Huh? What's the opposite of minus FF? Plus FF. So we plus FF on both sides. And we've isolated for FAP. So it's going to be MA, what's the mass? 70 times 0.82, that's MA, plus the force of friction. What's the formula for the force of friction? Mu Fn, and what is Fn? Beautiful. The mass is 70. Actually, I'll just write this out for you guys. I don't want to jump to conclusions. So 70 times 0.82, 57.4, plus mu, oh, I have mu, plug it in, and then mg. And the fact that Fn equals Fg is from the fact that, yeah, it's likely on a flat surface where the normal force is balanced by the gravitational force. Okay, so you'd have to apply a force of about 347 newtons. And my sig digs is off, but whatever. Why do you have to add the force of friction to F net? Right. Right. F net is the leftover, but we're trying to find the bigger force that supplies that leftover. So, put it this way. If you want something to accelerate, you have to meet the force of friction and then go on top of that. So, the applied force must meet the force of friction, and then if you want it to accelerate, you got to give it some more force. That's why it's a sum. you're going to see that that's how we do all the problems. Okay, this 700 newtons, force applied. It's being applied to a piano, giving it an acceleration. And then it says, what is mu? So your job right now is to just draw the free body diagram and come up with an F-net equation. So what do you guys got left and right? Force applied and force of friction. Is one bigger than the other? Yeah, good. So here's force applied. And here's force friction. If you look at that free body diagram, you can see that it's going to accelerate to the right. So the F net is the sum of all forces. And we're only focused on the left and right. So what do you got for the F net? Help me out. F applied minus force of friction. What do we know F net equals? MA. F applied is 700. And force of friction is mu F N. Plugging in what you know. 500 is the mass. A is 0.25. 700 minus mu. What's Fn equal? Fn equals Fg. From the free body diagram, Fn is Fg. Fn is mg. 500. 9.81. How do you solve this equation? It's just like you do them in grade 7. Just has a little bit more numbers. Put the equation on one side. Pardon me, put the variable on one side, put the number on the other. Maybe you want to simplify those values first. So I simplified the values. Now do you notice that the variable is on the right-hand side? The one that you want to solve for, mu, it's on the right-hand side. What sign is in front of it? So you could put that term on the left as a positive. So on the left, you can have 4905 mu. That means the 125 has to get out of the way. So you have to move the 125 to the other side. The 700 stayed put. So it's 700, take away 125. And then you have to divide out the 4905. This is mu right here. It's a beautiful thing. Algebra. What are the units on mu? No units on mu. Any questions about that one? Hopefully you were able to get that on your own accord. Okay, so this is the homework. I'll probably let you go at it for about 20 minutes and then we'll start another lesson.